Hello everyone, here's a quick discussion on something called significant figures. And the significant figures are a little bit strange, maybe a little bit ambiguous to us as we use them or why we use them. But basically what it says is that it validates whatever we're measuring, okay? So for example, if I were to measure something and I were to measure something that was like, I don't know, 111 grams, okay? I've measured 3 places, okay? And the 3 places that I've measured are all indicated by all these 3 ones here, okay? If I were to estimate something, let me do it this way. If I were to use something that's a little bit more sensitive, like a balance that is 111.1 grams, now I have another place that I can use as saying, hey, I measured that. That's good. So we can use that extra number, okay? So what this does is provide us a way to validate how exact we are, or our answer, I suppose, our calculations, okay? Validates our calculations. So with all the definitions that you see here, you can read those, but what we need to deal with is a set of rules. And the way I've done it is I've kind of broken it down here to something very specific, very quick, and that's this, okay? So the first thing is you have non-zero numbers right here, here, and here, right? Everything else is zero. So the tricky part of the zeros, okay? Do zeros count? In other words, were they measured? Do they not count? Were they just place holding? So this is it. If it's a non-zero number, it counts. You've measured it, okay? That's a significant figure. So far I have 4 arrows because I have 4 non-zero numbers, and therefore I have, so far, 4 significant figures that I've counted, and again, 4 numbers that are involved in my measurement, okay? All right, let's talk about these 2 green zeros, okay? The 2 green zeros, those count as being measured. Why? Because they're trapped. We call those trapped zeros, okay? Trapped zeros means they're a part of they're within non-zero numbers. So anytime they're trapped between non-zero numbers, it's part of our measurement. This is good, okay? So far I not only have the 4 non-zero numbers, but I also have the 2 trapped zeros. So right now in this whole big number here, I have, so far, 6 sig figs, okay? 6 sig figs, but there's more, okay? All right, anytime you have zeros to the right of any non-zero number, and it does not matter where the decimal is, anytime you have zeros to the right of a non-zero number, so here's our non-zero number right here, here's our zeros to the right of that non-zero number, those are good, those count. Those count as being part of our measurement. So now let's change our answer. We had started off with 4 non-zero numbers, then we added 2 trapped zeros. Now we're going to add 3 zeros to the right, so I have a total of 9 sig figs that I can count, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Now, here's the next question. What about the zeros to the left of any non-zero number? And let me say it again, it does not matter where the decimal point is. Those don't count. Those are placeholders, okay? And I can explain that a little bit better. But these don't count. So we do indeed have 9 significant figures, okay, in this weird example. So let me show you one more example of why this works, okay? Okay, let's say we have a balance. And on the balance, it's a very good balance. And I've measured something that has 0.123 grams, okay? So, I'm sorry, 0.0123 grams, okay? So I've measured this, and this. So why don't these zeros count? The reason why they don't count is I don't have enough matter. I haven't put enough matter on the balance to measure anything. There's no matter here. There is no matter here to measure, so they can't count. They're just holding places, okay? Now, let's say I go to Walmart and I buy a better balance, and I measure 0.0123 0. Okay, so this is even a more accurate balance. What that does is say I just happen to have 0.01230 grams. This 0 is simply by chance. So since it's a 0 by chance. So that means this counts. I have 4 sig figs in this whole big number here. In this tiny little number, okay? Now, you'd say, well, how is that not a placeholder? Well, let's say I leave the balance on overnight, and enough dust falls to make this a 2. Well, now it makes sense because it's a non-zero number. So why wouldn't it have counted before? The answer is it does. So any zeros to the right of non-zero numbers always count because it's part of our measurement. Zeros to the left of any non-zero number do not count. So if I could give you one more example, what if I have the following situation? What if I have here, how many significant figures? Again, you can pause at any time. The answer is 4. How many significant figures? Still 4. How many significant figures? Now there's 5. How many significant figures? 5. How many significant figures? A little weird. How many significant figures now? 3. 3. 3. 4. 4. You get the idea? 5. 6. Okay? So those are several examples which you guys can go through. Again, I rattled them off pretty quick, but again, just to reiterate, trapped zeros count. Zeros to the right of any non-zero numbers count. And any zeros to the left of a non-zero number, and again, it does not matter where the decimal place is, those don't count. To the left don't count, okay? Questions on this, let me know, but I'll see you in class.